So we've been talking about the objective being to sort of find out how many you need to get statistical significance. Occasionally the objective might be to say, well, I want to prove that the effect of these two treatments is equivalent, so that they're not different. So that's kind of turning things around a bit. The way that could be set up is you could say, well, I want my 95% confidence interval of the difference of the means, or the ratio of the means, to be in a specified range. I think something that's done in clinical trials is two treatments, if their ratio lies within, or the 95% confidence interval of their ratio lies between 0.8 and 1.2, that's taken to mean the treatments are equivalent. So that's then called a bioequivalence study. So the question is, what size of sample do I need to demonstrate that? And so if we think about an example where we're looking at the equivalence of two injections, the same example actually, the chlorum and the control injection, and we'll say, well, we'll conclude that they're equivalent if the red blood cell means are smaller than 0.4. So we require our 95% confidence interval to be between minus 0.4 and plus 0.4. And I've put that in red because it's wrong in the printouts. So it should have said 0.4, minus and plus 0.4. And it turns out actually that it's the same sample size calculation you need to be able to get that, because that's effectively the size of the difference you want to detect, or if it's there, but otherwise, if it's not there, you'll get your confidence interval within that range. So the calculation is exactly the same, and we come out, if we're looking at 0.4, then we need 20 mice per group, which is exactly the same as if we were looking for a difference of 0.4. So with 20 mice per group, we can be 80% certain, we've got a power of 80% of showing that the 95% confidence interval for the difference between the treatments is going to be within minus 0.4 and 0.4. When we're in that situation, we'll be able to conclude that the two injections were equivalent.